Welcome back. In this video, I'm going to show you how to use your dataset to train the network using CopyCat. And we can do this by feeding the dataset to CopyCat, which then learns to replicate the ground truth images so that the effect can later be applied to the entire sequence. CopyCat learns the best ways to make the input images look like the ground truth images, and then saves these out in a .cat file. So let's jump into the CopyCat properties and take a look at what they do. If you've watched the CopyCat Quick Start or my last course about creating maps with CopyCat, you may already be familiar with the CopyCat properties. So feel free to skip ahead and I'll put a timestamp in the description. So in the CopyCat tab, you can choose to use the local GPU for rendering if it's available, rather than the CPU. This is on by default as using GPU is faster. The data directory field is the path where the cat files and contact sheets are written to, so set that to your preferred location. Epochs is the number of times CopyCat processes the data set during the training. Increasing this number can often produce better results, but will have longer processing times. More epochs gives the model longer to train, but it is possible that earlier cat files can produce better results, so knowing how many epochs to use will take some experimentation. Some tasks will perform better with different values to others. For example, I'm going to start with 10,000 and see what the result looks like before increasing the value. You can stop and resume the training at any point if you want to see how the model is performing, and I'll go into more detail about monitoring the training and adjusting the options later on in this video. Next, you have some information telling you what channels are being processed from the input and ground truth. The channels in the upstream pipes are chosen automatically. So in my case, it is going to be RGB to RGB, as I haven't changed any of the other channels. You can also see the batch size, which is the number of image pairs to train the network with at each step. This is used to calculate the total steps, which is the number of epochs multiplied by the dataset divided by the batch size. You can manually increase or reduce the batch size in the advanced options by setting it to manual and entering a value. I'm going to leave it as it is on 4 for this specific run. Something to remember is that if you change the number of channels or number of inputs with the CopyCat properties open, you will need to close and reopen the properties, otherwise the information knob won't be updated. And then next there's buttons to start and resume the training. I'm not going to press anything yet, as I'm just going to cover the rest of the options first. So onto the advanced options. The initial weights option lets you set whether the training should begin from scratch or from weighting defined by a previous model. If this is the first time you're training the network for this task, then leave it at none. Otherwise, you can choose to use a previously trained cat file saved in the data directory. Later on in this course, I will show you how to use a pre-trained cat file to apply our results to multiple shots. The model size and crop size options are trade-offs between speed and quality. Increasing the values could cause you to run out of memory, so some experimentation with these is probably required. Small models are faster to train and use the least GPU memory, but large models may produce better results. For this example, I'm going to use a large model, as some initial experimentation has shown that this size produces the best results for this particular task. But again, you may want to start off with a medium size and see how you go. The crop size defines the size of the random crops taken from the dataset image pairs. As I said in the previous video, during training, these random crops are taken and compared against each other. So larger crop sizes can produce more accurate results, but at the expense of processing time and memory. It's probably a good idea to have a play around with these settings to find out what works best for you and your machine and the task you're working on. If the training seems to be taking a long time, you can try reducing the crop and model sizes, as well as the batch size, depending on the task. And you can use the checkpoint interval and contact sheet interval options to determine how often CAT and PNG files are written to the data directory. For example, a total steps value of 5,000 and a checkpoint interval of 1,000 would produce 5 CAT files over the course of the training. So now I'm going to start the training and switch over to the Graphs tab. In this tab, you can view the training progress represented as a graph of steps against loss, where the steps are the total number of steps that the training needs to complete, and the loss is the value of difference between the ground truth and the image that the network will produce at that step. It is important to monitor the training at the beginning to see if there's any errors in the setup, and just to make sure that nothing's going wrong. After this, if it looks like the training is running as expected, then you can leave it while working on other things. But it is probably a good idea to check in every so often. And you should see the graph for the current training steadily decline towards 0 on the loss axis. You can adjust the smoothness slider to get an idea of the general trend of the graph. When your graph starts to flatten off, which should be later on in the training, you can use the log scale option to see more detail at the lower loss values. If your graph is going up or staying flat at this early stage, when the training's just started, then it means you may have an issue with your setup. If this is the case, you should double check your input and ground truth images are in the same order, and maybe experiment with increasing your model or crop sizes for better results. So while the training is running, you will also be able to see in the viewer a crop overlay grid. And this can be a really good way of quickly spotting any obvious mistakes with your setup. For example, if the input and ground truth images don't line up, then it means they've not been inputted to the append clip nodes in the same order. It's also a good way of seeing how the network behaves on certain frames. The size of the crops are the specified crop size, which is why increasing that crop size can produce better results, but will take longer to process. So the input and ground truth are the images from our dataset, and the output has the effect that the network has learned so far applied to the source image. With beauty work, the process of learning the desired effect may take a lot longer than other tasks, such as garbage matting. Therefore, it may take a while to see something that looks like the effect we're aiming for in the overlay images. At first, the output crop will probably look like a random colored version of the input, but with time, it will start looking more and more like ground truth. This overlay is saved to the data directory as a PNG according to the contact sheet interval, so every 100 steps by default. The graph and contact sheet are designed to be used together, so don't worry if the contact sheet results are not perfect. As long as the graph trends towards 0, then your training should be performing as expected. But another way to monitor the training is to use the preview input on the CopyCat node itself to view the training progression in the viewer. And you can use this to see what the training looks like on frames outside of the dataset and potentially spot if there's any big issues. You don't have to use this input. By default, a PNG preview file is saved out to your data directory every 1,000 steps. So you can look at that instead if you like. And you can change how often this preview is saved out using the checkpoint interval. If, after the training has been running a while, the graph is trending towards 0 but the output column is still not replicating the ground truth, you can try increasing the number of epochs in the run. And if you do this, you don't need to start the training again. You can simply cancel it, increase the epochs, and then resume the training. And it will pick up from where it left off, but will just be running for longer. If you think that the training is not achieving the desired effect, you can try adding more image pairs to the dataset, because a diverse selection of images tends to produce the best results. And the more frames you use, the better the results are likely to be. For example, in this shot, as I said, I chose frames, one where there is a shadow over the bruise and one where there is not. Do bear in mind that while the training is in progress, you can work on other tasks on the same computer and even open up a new instance of Nuke and work on other scripts. By doing this, you can really see the benefit of using CopyCat, as you can effectively be working on 2 separate tasks at once. So I'll leave this to train, and in the next video, I'll show you how you can apply the results to the rest of the sequence and make some improvements.